Hi, this is Loci from Beta Folders. We're looking at small molecule design again. Let's take a look at how to move the small molecule, the ligand, to a better spot where we can work on it. Now you see I've selected the ligand here, and the move tool was already selected, but if not, you can get it with the 3 keyboard shortcut or the icon on the taskbar. And then just hover over the purple cross, which is a little hard to see here, hold down the control key, and drag the ligand to the spot you want it. And so we can use that to move the protein off the screen, and that makes it easier while we're designing the ligand, and then later on we can move the ligand back toward the protein. But when we click and drag on the background, it's still like a bad 3D movie. We're not getting smooth rotation. And that's because if we look at the protein, we'll see that the purple cross of the move tool is over in the center of the protein, and so that's really the center of rotation. But there is a way around this. If we hover over the ligand and hit Shift plus Q, that focuses on the ligand, and now when I drag on the background, the ligand is the center of rotation. Thanks to my teammate Bertro for this excellent tip. Makes life a lot easier. There are a couple of other controls that adjust the visibility of the ligand or the protein. If we hold down Control and Shift and drag up or down on the screen, that adjusts the far visibility. If we hold down Control and Alt and drag up or down the screen, that adjusts the near visibility. And if we hold down Alt and Shift, that adjusts the fog. And that tends to come in from the background as well, so it's kind of an alternative to the far visibility tool. But now we can rotate the ligand just fine, and I've adjusted the far visibility to show the whole thing no matter how it's rotated. So that's kind of the mode that we want to be in to work on this ligand. Next, let's go back and look at TPV, tipranavir, the protease inhibitor we built in the first video. And that had a small problem with what we call the second ring. There was an extra hydrogen next to this oxygen atom. And let's take a look at the model here. Again, we're looking in JMOL, and we can see at the same spot that there's just a carbon atom there. There is a double bond to the next carbon atom, but no extra hydrogen. So let's try to fix that up. Let's get into ligand design mode. We'll select the carbon and the adjacent carbon. Then we'll click on double bond. So that converts the bond between the two carbons to a double bond, as we see in the model. And when we do that, the hydrogen, the extra hydrogen, vanishes. Now let's take a look at a different molecule, darunavir, or DRV, another protease inhibitor. Let's go into JMOL first. Do File, Get PDB, and I happen to know that darunavir is code letter O17, not as mnemonic as TPV. So here's the molecule, and if you look at this, you'll probably quickly notice that there's kind of an unusual feature at one end of this. There's this kind of carbon cluster here, and it almost looks like 2 rings stacked. And here's my first attempt to build it and fold it, and there's something that's not quite right here, because if you look at that, that's kind of a tube. So let's delete some of those extra atoms there, and we can select multiple atoms in the ligand design mode and delete them. But you have to be careful to not leave anything hanging off the tree, so to speak. If you do that and you try to delete, it won't let you. Going atom by atom, I've paired it back to this nitrogen. And now I'll add a cyclohexane ring to that. This is how I did it the first time. Then I'll add another cyclohexane ring to the far end of the first one. And now I'll select 2 sort of adjacent hydrogen atoms. And I'll click single bond. Okay, so that's an example of where selecting a hydrogen atom does not extend the molecule. And I'll do the same thing over on this side. So I've got the structure that I had before, but it's not quite the structure that we're seeing in JMOL. So it is these 2 stacked rings held together by 3 struts. So back in JMOL, we can see that there's actually a carbon in the center. So that's not the structure we had. So let's just delete the second ring, just doing Control Z. And now we're back to our one cyclohexane ring. So now let's get into ligand design mode again. And we'll select the 3 hydrogens on one side and extend by adding carbon atoms. And then we'll select one of the hydrogens and add the center carbon that'll connect the 3 struts. Now we'll select a hydrogen and a hydrogen. We will single bond them together. Sometimes it takes 2 tries to do this because it's easy to select the wrong atoms. Okay, there we go. Second time's the charm. Let's do that for the third. Okay, so now we have the 3 struts with a single carbon atom in the center. And unlike the first attempt, there's no penalty here. Foldit thinks that we could synthesize this particular ligand. Now let's try to build our own rings. We'll start with the initial molecule in puzzle 1519. And we'll just select a hydrogen and add a carbon. And then we'll add 6 more carbons. And we'll try to get them kind of going in a ring-like direction here. But as usual, we're not paying too much attention to the specific geometry. And once we get 6 carbons added, we'll select 2 somewhat nearby hydrogens. Okay, we're at our 6. Let's select 2 hydrogens and click single bond. Okay. So now we have what looks like a cyclohexane ring. So let's see if we can make it into a benzene ring. We'll select 2 adjacent carbons and convert them to a double bond. Then we'll skip a carbon, select 2 adjacent carbons, convert it to a double bond, skip a carbon, and repeat. So now we have what appears to be very much like a benzene ring. And if you select 2 carbons on that benzene ring, you can add another benzene ring. Click. And you can select 2 carbons on that benzene ring and add another benzene ring. And you can keep going. And Foldit is still happy with that. 3 benzene rings in a row. And this is an example of whereas previously we said that selecting hydrogens is the way to extend. In some cases you can also extend by selecting a heavy atom, or even 2 heavy atoms. And you can go, oops, now we're getting into a penalty there. Our C log P has gone too high. Just another example, but you can also extend by selecting a single heavy atom, a single carbon in this case. And you can add a benzene ring to that carbon. So the 2 will only share 1 attachment point in that case, not 2 as before. To wrap things up, we've seen how selecting 2 hydrogens lets you bond them together if they're close enough, and selecting 1 or 2 heavy atoms lets you extend, adding a ring. That's all for now. In an upcoming video, we'll take a look at how to get these atoms into the correct shape. We're playing fast and loose with that so far.